Part 1. In October of 1971, internal maintenance records from the Black Ridge Mining Complex in eastern West Virginia documented a closure order involving Shaft 14B, a secondary extraction corridor that had operated intermittently since the late 1940s. The order itself was unremarkable on paper. Underground collapses were common in older sections of Appalachian coal networks, particularly in shafts expanded during wartime production years, when reinforcement standards varied widely between operators. The typed report referenced unstable support beams, abnormal wall pressure, and increasing methane concentrations along the lower eastern branch. By the standards of the period, none of this stood out. What stands out is that the section was filled in completely less than 4 days after the final descent. The records indicate that the last miner officially assigned to enter the sealed branch was a 39-year-old maintenance operator named Daniel Harker, a contract employee responsible for rail inspection and pump evaluation inside inactive corridors. His entry timestamp appears in a shift log dated October 11, 1971, at 6:42 a.m. The return timestamp field was left blank. There are no reports describing panic underground. No emergency evacuation order appears in county records. No public statement was issued regarding a collapse. Local newspapers from Boone County mention routine maintenance delays at the mine that week, but nothing more. Yet internal documentation shows that by October 15th, heavy fill operations had already begun inside 14B using slurry concrete and crushed aggregate, a method generally reserved for permanent abandonment. The speed of the decision becomes difficult to ignore when compared against normal mining procedures of the period. Federal guidelines following the Federal Coal Mine Health and Safety Act of 1969 required extensive surveying before complete shaft closure. Inspectors usually documented structural failure patterns, methane migration pathways, and remaining equipment inventory. In this case, several expected pages are absent. The section was later removed from revised site maps entirely. Former employees interviewed decades later described the area in unusually consistent terms. Most referred to the eastern branch as the low corridor because of a gradual decline that extended beyond mapped grade measurements. According to drilling surveys from 1956, the tunnel should have intersected a sandstone barrier approximately 200 feet past Marker Junction, E7. Instead, expansion crews continued excavating for nearly another quarter mile. No official explanation was provided for the discrepancy. A retired blasting technician named Walter Baines gave a recorded interview in 1998 to a regional labor historian documenting abandoned mine practices throughout Appalachia. The interview was not publicly archived for years. In the recording, Baines recalled that compass readings inside the eastern branch frequently drifted several degrees off alignment, particularly near moisture-heavy sections where exposed rock walls produced minor electrical interference. Such disturbances were not unheard of underground, but he also noted repeated complaints involving timing irregularities. Workers reportedly believed watches ran slow inside the lower corridor. At first glance, this sounds like the kind of folklore common to isolated labor environments. Mines produce stories the way ships did. Men working underground for 10 or 12 hours often attached meaning to darkness, compressed air acoustics, and exhaustion. But maintenance records from the period contain references that complicate the dismissal. Several equipment logs from 1968 through 1971 document recurring synchronization, problems involving electric rail timers used to coordinate transport movement between surface elevators and lower extraction levels. In at least 5 entries, operators manually recalibrated clocks after entering the eastern branch because elapsed travel time did not match expected distance calculations. The data does not fully align with ordinary mechanical drift. One report filed in February 1970 by shift engineer Leonard Vail noted that a transport car traveling from junction E2 to E9 required 19 minutes longer than expected, despite no obstruction being found on the rail line afterward. Vail attributed the discrepancy to electrical interference, though later inspection notes mention no damaged circuitry. Similar reports began appearing in adjacent mining operations within the same geological basin. By early 1972, 2 inactive shafts in neighboring counties documented nearly identical instrumentation irregularities. At the Red Hollow mine near Logan County, underground survey teams recorded repeated compass deviations exceeding accepted magnetic tolerance thresholds. Further south, in a privately operated extraction site near Pine Creek, maintenance workers complained that communication lines carried delayed echo patterns even after cable replacement. Individually, these incidents remained minor. Collectively, the timeline becomes difficult to ignore. The Harker file itself grows stranger under closer examination. His personnel record ends abruptly after the October 11th entry. There is no termination form, no death certificate connected to the mine, and no documented compensation claim filed by surviving relatives. Payroll records show final payment issued automatically through November, before the employee identification number was permanently retired. Researchers examining county archives in the early 2000s discovered that the mine's weekly labor report for October 1971 contained one additional anomaly. The page listing underground staffing totals had been physically replaced with a duplicate copy typed on a different machine. The spacing between characters differed slightly from surrounding pages, and one line item referencing maintenance personnel had been removed entirely. No official explanation was provided. If you've been following these patterns, you'll start to notice that the uncertainty surrounding Shaft 14B does not come from a single dramatic event. It emerges from administrative inconsistencies, missing timestamps, altered maps, accelerated closure procedures, equipment logs that describe measurable irregularities without interpretation. None of the records claim anything extraordinary occurred underground. In fact, the opposite seems true. Every document attempts to frame the situation as routine. And yet, routine closures do not normally involve overnight concrete sealing operations supervised by outside contractors. Invoices from Mid-Atlantic Industrial Containment Services confirm that 14 trucks were dispatched to Black Ridge between October 13th and October 15th. The quantity of fill material delivered exceeded the estimated volume required for the mapped dimensions of the shaft by nearly 30%. The excess material was never accounted for. By itself, that detail could still be explained through overestimation or poor reporting. But interviews conducted years later with transport drivers introduced another recurring element. Multiple drivers recalled being instructed not to stop near the lower staging platform during unloading. One described hearing machinery operating below the sealed section long after official closure orders had supposedly taken effect. Another remembered armed security personnel stationed near the descent elevator. Private security at mining operations was not unusual during labor disputes, though no strike activity was reported at Black Ridge that month. More difficult to explain are the references found in communication logs exchanged between Black Ridge management and the United States Bureau of Mines regional office in Pittsburgh. Several telegram summaries from late October mention containment integrity and continued acoustic events inside the abandoned branch. One heavily redacted memo includes a recommendation that no further drilling occur within a specified exclusion radius until pressure stabilization could be verified. Pressure from what is never clarified. The Eastern Appalachian Basin contains thousands of abandoned shafts, many poorly documented and structurally unstable. Subsurface collapses, gas pockets, and acoustic anomalies are all established phenomena. But beginning in the early 1970s, scattered records from multiple states start describing something more difficult to categorize. Not catastrophic events exactly, but recurring inconsistencies tied to isolated underground corridors that were later sealed, removed from maps, or quietly transferred to federal oversight. And in nearly every case, the same pattern appears first. A maintenance worker enters an inactive section. Instrumentation begins behaving unpredictably. The section is closed, then the records change. Part 2. By the spring of 1972, references to unusual underground conditions were no longer confined to Black Ridge documentation. Similar reports began appearing across unrelated extraction sites stretching from West Virginia into eastern Kentucky and southern Pennsylvania, often buried inside maintenance summaries or engineering appendices, where they attracted little attention outside technical review boards. The wording remained cautious. Operators described acoustic distortion, unexplained air pressure fluctuations, electrical instability, and surveying inconsistencies that exceeded normal geological variance but stopped short of identifying a cause. What stands out is not the severity of any single incident, but the repetition of language between companies that otherwise shared no administrative structure. At the Linton No. 3 mine near Pikeville, Kentucky, an April 1972 inspection report documented what supervisors referred to as distance uncertainty inside a disused lower corridor. Two survey teams measuring the same branch produced conflicting tunnel lengths separated by nearly 60 feet. Recalculation corrected nothing. The section was sealed later that summer. No official explanation was provided. Internal correspondence from the mine's parent company suggested concern over persistent navigational inconsistency, a phrase unusual enough that later investigators highlighted it repeatedly in archival reviews. The records indicate that workers navigating the lower branch often reported reaching support markers earlier or later than expected, despite following fixed rail lines. Again, taken individually, such observations could be dismissed as exhaustion, low visibility, or inaccurate memory. Underground environments distort perception. But the data does not fully align with that explanation because instrument measurements began reflecting the same uncertainty. One memorandum from June 1972 described repeated failures involving calibrated measuring reels that returned conflicting distance readings during consecutive surveys performed only hours apart. Engineers initially blamed thermal expansion caused by humidity variation. Follow-up tests conducted above ground produced no comparable discrepancies. This was not an isolated case. In August of that same year, the Bureau of Mines received an incident summary from a zinc extraction site near Balmat, New York, nearly 500 miles from Black Ridge. The geology differed entirely from Appalachian coal structures, yet the reported anomalies shared remarkable similarities. Workers assigned to inspect a flooded lower tunnel experienced severe communication delays through wired field telephones. According to one technician's statement, spoken responses occasionally returned several seconds after transmission had ended. The phenomenon was attributed officially to moisture interference in aging cables. However, maintenance notes filed afterward mention that replacement lines produced the same effect. The timeline becomes difficult to ignore because closures followed these reports with increasing speed. Areas once scheduled for rehabilitation instead underwent permanent containment. In several cases, records describing the affected corridors vanished from later operational maps altogether. Researchers examining federal mining archives during the late 1990s discovered that at least 11 shaft sections referenced in early 1970s inspection records no longer appeared in revised geological indexing systems, published after 1975. Some omissions may reflect bureaucratic simplification. Others are harder to reconcile. One Pennsylvania corridor identified in a 1971 methane study simply ceased existing in later federal inventories, despite extensive earlier documentation. The section was later removed. The pattern expanded beyond mining. Deep tunnel construction projects initiated during the same period began producing parallel observations, particularly in infrastructure work requiring extended excavation through dense sedimentary rock. In 1973, engineers working on a hydroelectric diversion tunnel near the Virginia-Tennessee border documented repeated synchronization failures between surface and underground timing systems. Workers below ground consistently reported shorter shift durations than surface supervisors recorded. No definitive malfunction was identified. A review board ultimately blamed inconsistent timekeeping procedures among crews. Yet attached notes from the project engineer included a statement rarely cited outside technical archives. Temporal reporting variance remains operationally significant despite instrumentation replacement. That phrase appears nowhere else in public construction records from the period. By 1974, the Bureau of Mines had quietly assembled a restricted distribution report examining what it termed subsurface orientation anomalies. The document itself remains partially classified, though excerpts surface through Freedom of Information requests decades later. The surviving pages avoid speculative language entirely. Instead, they catalog recurring categories of disturbance observed across multiple underground sites, among them, compass deviation beyond geological expectation, acoustic reflection inconsistency, elapsed time disagreement between mechanical and electrical timing systems, perceptual distance variation among workers navigating fixed corridors, and, most notably, elevated rates of abrupt shaft abandonment following these reports. The report offered no conclusion. What stands out is that the Bureau did not recommend expanded public investigation. Instead, it proposed centralized data handling through interagency review channels involving geological, defense, and energy offices. Why defense agencies became involved remains unclear. Several historians studying Cold War infrastructure policy point out that the early 1970s saw significant overlap between federal mining surveys and underground continuity of government projects. Deep excavation sites were strategically important for communications research, energy storage, and hardened emergency facilities. Certain mining corridors were occasionally repurposed for classified testing involving seismic monitoring equipment. But there is no public evidence directly connecting those programs to the abandoned shafts described in these records. Only proximity and recurring administrative overlap. One of the more revealing cases emerged from a decommissioned limestone quarry outside Parkersburg, West Virginia, where university researchers conducted acoustic propagation studies in 1975. The experiment itself was straightforward. Transmit controlled sound pulses through excavated chambers to evaluate subsurface communication potential. The data produced unexpected inconsistencies. According to surviving university notes, certain signals returned distorted timing intervals that could not be replicated reliably above ground. Researchers initially suspected equipment calibration issues, but after multiple control tests, one observer noted that echo separation intervals appear non-stationary relative to chamber position. Funding for the study ended shortly afterward. The section of quarry used for testing was permanently restricted. No official explanation was provided. If you examine enough of these cases side by side, another pattern emerges beneath the technical details. The anomalies were rarely treated as dangerous in a conventional sense. Reports do not describe toxic exposure, mass hallucination, or catastrophic structural failure. Instead, institutions responded as though the primary concern involved unpredictability itself. Areas were isolated, maps were revised, data channels were centralized. Studies were halted before conclusions could solidify, and workers directly exposed to these environments often disappeared administratively rather than physically. That distinction matters. Daniel Harker was never declared dead. Several other names connected to similar incidents follow the same pattern. Employment records end without formal closure. Insurance claims vanish mid-process. Personnel files become incomplete. In one Kentucky case, a surveyor assigned to a sealed branch remained listed as inactive temporary transfer for nearly 6 years after the corridor itself had been filled with concrete. The records indicate no transfer destination. Former federal archivist Helen Mercer addressed this issue indirectly during a lecture in 2004 concerning fragmented industrial databases from the Cold War era. She argued that certain categories of records were intentionally rerouted between agencies to avoid public disclosure during periods of infrastructure sensitivity. While she never mentioned mines specifically, one statement drew attention from later researchers. There are instances, she said, where maintaining uncertainty was considered administratively preferable to issuing conclusions unsupported by existing models. Maintaining uncertainty. That phrase appears repeatedly in internal memoranda tied to restricted geological studies during the 1970s. Not proving, not disproving, containing. And by the late 1970s, containment procedures surrounding anomalous underground sites had become increasingly standardized. Permanent fill, restricted access, map revision, interagency review. Then silence. Part 3. The deeper investigators moved into federal archives. The more the scattered mining incidents began resembling components of a coordinated administrative framework rather than unrelated industrial accidents. Not a conspiracy in the conventional sense, but a procedural system designed to absorb irregular data without public interpretation. The records indicate that by 1976, at least 3 separate agencies were exchanging reports connected to underground orientation anomalies: the Bureau of Mines, the United States Geological Survey, and an energy research division operating under the newly formed Energy Research and Development Administration, later incorporated into the Department of Energy. Most communication remained technical and heavily compartmentalized. What stands out is how often ordinary geological terminology gave way to unusually abstract language once discussions moved beyond local mining offices. Terms like field instability, non-repeatable spatial behavior, and localized temporal displacement reporting begin appearing in interdepartmental summaries despite lacking standardized definitions. The data does not fully align with conventional mining analysis. One restricted memorandum dated February 1977 referenced recurrent inconsistencies between observed traversal duration and mapped linear distance across multiple underground facilities. Another suggested that certain excavation geometries appeared to amplify orientation degradation effects under conditions not fully understood. No official explanation was provided. At approximately the same time, several universities conducting subterranean acoustic and magnetic studies experienced abrupt funding interruptions. Publicly, these cancellations were attributed to budget restructuring following the energy crisis of the 1970s. Privately, correspondence between administrators reveals growing concern over findings considered methodologically destabilizing. That phrase appears in a partially recovered exchange involving a research team at Carnegie Mellon University studying deep earth resonance behavior in abandoned industrial tunnels. The project ended before publication. Equipment inventories associated with the study were transferred to a federal storage facility in Maryland. The section of tunnel used for testing was sealed less than 2 months later. This was not an isolated case. Records from the University of Kentucky show that a geophysics team examining low-frequency seismic distortion inside abandoned coal chambers lost access to field locations shortly after submitting preliminary findings to a federal review board in 1978. One researcher later described receiving instructions to suspend all independent analysis involving nonlinear spatial measurements underground. No formal prohibition exists in surviving documents. Only requests, repeated requests, and gradual administrative pressure. If you've been following these patterns, you'll notice that suppression rarely appeared as direct censorship. Data was not openly denied. Instead, access pathways narrowed quietly over time. Reports became harder to retrieve. Funding disappeared. Archive references changed classification categories. Physical sites became inaccessible due to safety stabilization. The effect was cumulative. By the early 1980s, many of the original corridors associated with anomalous reports no longer existed in operational records at all. Black Ridge Shaft, 14. B remained among the few cases where enough documentation survived to reconstruct a partial timeline. Yet, even there, crucial inconsistencies persist. For example, freight manifests from October 1971 indicate that additional industrial equipment was transported into the mine after the official closure date rather than before it. The manifests list atmospheric monitoring arrays, portable generators, and insulated communication reels delivered under subcontract authorization from a federal procurement office. Why equipment was moved into a sealed section remains unclear. More unusual still are references to repeated acoustic events occurring after fill operations concluded. A maintenance supervisor identified only as R. Keller documented subsurface reverberation episodes detected through inactive ventilation at shafts nearly 3 weeks after shaft. 14B had supposedly been stabilized permanently. Keller described low-frequency mechanical sounds recurring at irregular intervals beneath the sealed eastern branch. The report recommended no excavation attempts. Instead, additional concrete reinforcement was ordered. The timeline becomes difficult to ignore because similar post-sealing observations appear elsewhere. At a copper extraction facility in Montana, workers monitoring groundwater contamination near an abandoned shaft recorded vibration signatures months after complete structural collapse had supposedly rendered the tunnel inaccessible. In Nevada, geothermal survey crews reported intermittent magnetic interference centered around a filled exploratory bore network removed from federal maps years earlier. Again, none of the reports claim extraordinary phenomena, Most avoid interpretation entirely, but the consistency of institutional response suggests that officials encountered recurring conditions they considered operationally disruptive, not necessarily dangerous. Disruptive. A particularly revealing development occurred in 1981 when portions of the Bureau of Mines anomaly files were transferred into a newly organized records category associated with infrastructure continuity planning. Several pages released later through archival review contain references to navigational integrity risks affecting underground facilities intended for emergency governmental use. That detail changed the context significantly. Cold War continuity infrastructure depended heavily on accurate underground mapping, stable communications, and reliable movement timing through hardened subterranean corridors. If certain geological environments produced unpredictable spatial or temporal inconsistencies, even minor ones, the implications for military planning would have been substantial, and yet public discussion remained non-existent. One reason may involve the ambiguity of the phenomena themselves. The records never establish a coherent mechanism. Some researchers suspected unusual electromagnetic interactions caused by mineral density and confined geometry. Others propose psychological distortion resulting from sensory deprivation underground. Neither explanation fully accounts for the instrumentation irregularities documented across multiple sites. Mechanical clocks drifted, electrical systems desynchronized, survey measurements conflicted, acoustic reflections returned inconsistently. The data does not fully align. By the mid-1980s, direct references to underground orientation anomalies become increasingly rare in accessible federal records. But disappearance itself forms part of the pattern. Programs did not conclude publicly. Terminology changed instead. Documents once categorized under geological instability migrated into broader infrastructure resilience archives. Site identifiers vanished behind revised indexing systems. Some physical locations were absorbed into federal land management zones, where excavation access became permanently restricted. The section was later removed, again and again. One former contracting engineer, interviewed anonymously in 1996, described participating in containment work involving abandoned tunnel systems throughout the eastern United States during the late 1970s. He claimed crews were instructed to reinforce selected corridors far beyond ordinary collapse prevention standards. When asked why, he answered carefully, "Because nobody trusted the measurements anymore." He offered no elaboration. No official explanation was provided. Perhaps the most unsettling detail emerges from comparison studies conducted years later by independent archivists. Across dozens of cases involving sealed underground sections between 1971 and 1984, one recurring sequence appears with remarkable consistency. First, workers report perceptual or instrumentation inconsistencies. Second, technical surveys attempt verification. Third, access restrictions intensify. Fourth, records fragment. Then the physical site disappears from public systems. Not every case followed the exact pattern. Some ended after ordinary geological findings. Others remained too incomplete to evaluate. But enough examples survive to suggest that institutions encountered something they could document operationally without being able to explain theoretically. And institutions tend to react predictably to unresolved variables. They isolate them. They standardize procedures around them. Then they remove them from view. Yaosish Part 4. By the beginning of the 1990s, most of the original personnel connected to the early shaft incidents had either retired, died, or disappeared into fragmented employment records that no longer aligned cleanly with surviving archives. Entire mining regions had transformed economically. Companies dissolved, merged, or declared bankruptcy. Physical evidence vanished beneath collapsed earth. Reclaimed forests, industrial redevelopment, and federal land transfers. Yet the pattern persisted in documents, not openly, indirectly. What stands out in later reviews is how consistently investigators encountered absence itself as evidence. Missing survey pages, incomplete map revisions, inaccessible storage catalogs, unexplained classification shifts, and references to reports that no longer existed where indexes claimed they should. The records indicate that independent researchers attempting to reconstruct the anomaly cases often arrived at the same conclusions separately. Whatever institutions were responding to underground, they considered uncertainty more manageable than explanation. That distinction shaped everything that followed. In 1992, a consulting geologist named Martin Keene submitted a comparative analysis to a private industrial safety board examining historical shaft abandonment procedures across Appalachia. Keene was not investigating anomalies directly. His focus involved structural risk management, but buried within the appendix of his report was a statistical observation that later attracted attention. Sites associated with unexplained instrumentation discrepancies were sealed, on average, nearly 4 times faster than sites involving confirmed geological instability. No official explanation was provided for the discrepancy. Keene also noted unusually high rates of cartographic revision surrounding those same locations. Coordinates shifted slightly between additions. Tunnel lengths changed without notation. Certain lower branches disappeared entirely from later survey maps, despite earlier documentation confirming their existence. At first glance, bureaucratic inconsistency might explain this. Mining archives were notoriously fragmented, but the timeline becomes difficult to ignore because the revisions consistently followed reports involving orientation irregularities. Never before, always after. Around the same period, advances in digital archival systems unintentionally exposed additional anomalies. During the conversion of older geological records into computerized databases, technicians discovered metadata conflicts involving underground site dimensions entered decades earlier. In several cases, mapped tunnel volumes did not mathematically correspond to recorded excavation output. More material had reportedly been removed from certain shafts than the documented tunnel systems could physically contain. Accounting error remains the official explanation. Still, some engineers reviewing the data privately acknowledged that the inconsistencies exceeded ordinary clerical drift. One internal note from 1994 described persistent volumetric disagreement across multiple abandoned extraction sites previously associated with restricted access classifications. The phrase appears nowhere in public summaries. If you examine enough of these records together, the philosophical implications begin emerging almost unintentionally. Not because the documents prove anything extraordinary, but because they reveal repeated institutional encounters with environments where measurement itself became unstable. Distance behaved inconsistently. Elapsed time conflicted between systems. Spatial orientation degraded. Acoustic reflections refused to normalize. And rather than announcing discoveries, institutions responded through containment. That response may be the clearest evidence available, not evidence of hidden creatures, secret experiments, or supernatural events. The archives support none of those conclusions directly, but evidence that certain underground conditions repeatedly produced results resistant to standard modeling. The data does not fully align. One of the final known references to Black Ridge Shaft, 14B, surfaced unexpectedly in 2001 during an environmental reclamation assessment conducted after severe flooding across portions of southern West Virginia. Engineers reviewing historical groundwater pathways encountered discrepancies between modern terrain scans and archived geological maps from the early 1970s. According to the assessment notes, subsurface density readings suggested the existence of a void structure extending beyond the officially sealed boundary of the eastern branch. The dimensions did not match surviving mine diagrams. Follow-up drilling was proposed briefly, then withdrawn. The section remained undisturbed. No official explanation was provided. That same year, an internal memorandum from a regional environmental office recommended against deep subsurface penetration activities near several abandoned Appalachian corridors, pending further review of historical stabilization records. Attached references cited legacy federal restrictions originating in the late 1970s. Again, terminology shifted. No mention of anomalies, no discussion of instrumentation drift, only procedural caution. But by then the pattern had already become visible to those tracing archival continuity across decades. The same sites reappeared repeatedly beneath changing classifications and revised administrative language. Mining safety, geological instability, infrastructure resilience, environmental containment, different labels, consistent locations. and always the same operational sequence: survey, restriction, sealing, removal, silence. Perhaps the most revealing aspect of the entire history is how ordinary the records remain individually. None contain dramatic declarations. No recovered document states that physical laws failed underground. No surviving official ever claimed that tunnels changed shape or that time itself behaved differently below the earth. Instead, the unease emerges statistically, across decades, across agencies, across unrelated excavation sites connected only by recurring measurement instability and unusually aggressive containment procedures. The contradiction is subtle but persistent. Institutions continue documenting the anomalies long after publicly dismissing them through ordinary geological explanations. Studies were halted, but monitoring persisted. Sites were sealed, yet post-closure surveillance continued. Maps were revised, but exclusion zones remained active. If the anomalies were meaningless, the response appears excessive. If the response was precautionary, the underlying concern was never articulated, and that leaves a narrow space occupied entirely by uncertainty. The last confirmed descent into Shaft 14B still belongs officially to Daniel Harker on the morning of October 11, 1971. His timestamp remains incomplete. The eastern branch no longer appears on modern public maps of the Black Ridge complex. The section was filled in days later using quantities of material that exceeded documented dimensions. Subsequent federal memoranda referenced continued acoustic events beneath the sealed corridor, while simultaneously discouraging further excavation. None of those details prove anything independently. Together, they form a pattern difficult to dismiss entirely, especially because the same sequence appears elsewhere, again and again. Different states, different companies, different geology, yet similar instrumentation failures, similar administrative reactions, similar disappearances inside the record itself. Perhaps that is why the surviving documents feel unsettling even now, not because they reveal a hidden answer, but because they preserve the outline of institutions confronting something they could measure repeatedly without fully describing. And when systems built on measurement begin quietly removing locations from their own maps, the implication is not necessarily that reality changed underground, only that, for a period of time, the people responsible for defining reality on paper no longer trusted their own measurements inside certain places beneath the earth. The records indicate they responded by sealing those places permanently. What remains unclear is whether the closures ended the problem, or merely removed it from view.